Good morning, student. Today we will going to revise chapter number 3. Chapter number 3, trigonometric function. Uh, in miscellaneous exercise, question number 2. Prove that sine 3x plus sine x bracket over whole bracket over means sine 3x plus sine x bracket over outside sine x plus cos 3x minus cos x bracket over cos x is equal to 0. Means prove that this term is 0. So now start from the LHS side. So in LHS side, here sine plus sine form is present. That means here apply the identity s plus s. S plus S, that means 2SC, and here C minus C form is present. So C minus C, that means minus 2SS. So here apply this identity. S plus S, that means 2SC. So here written 2 times sine 3x plus x divided by 2 into cos 3x minus x divided by 2 bracket over now into sin x plus same way here c minus 2ss. So minus 2 times sin 3x plus x divided by 2 into sin 3x minus x divided by 2 bracket over into cos x. Now after simplify this term, so is equal to in bracket 2 times sine 3x plus x means 4x divided by 2, that means sine 2x. 3x minus x, that means 2x divided by 2. So cos x bracket over sin x. Now minus 2 times sine 3x plus x divided by 2. So here written sin 2x into sin x into cos x. Now here both these terms same, so cancel out this term and our answer is 0. Right? So our proof is 0. So here 2 term is present. Now here in bracket form is present. So here apply the identity s plus s, and here in another bracket apply the identity c minus c. Now simplify this term. So here we get final answer. Now after question number 3. In bracket cos x plus cos y whole square plus sin x minus sin y whole square is equal to prove that 4 times cos square x plus y divided by 2. So again here start from the LHS side. Here cos x plus cos y whole square is present. So here we can apply the identity, that means c plus c identity apply in this bracket. Now in another bracket s minus s form is present. So here also apply the identity. So c plus c, we know that c plus c, that means 2cc, and s minus s, that means 2cs, right? So here apply this identity. So in bracket c plus c, that means 2 times cos x plus y divided by 2 into cos in bracket x minus y divided by 2 whole square plus in another bracket s minus s, that means 2cs. So 2 cos x plus y divided by 2 into sin x minus y divided by 2 bracket over whole square. 2 square, that means 4 cos square bracket x plus y divided by 2 into cos square x minus y divided by 2 plus 2 whole square, that means 4 cos square bracket x plus y divided by 2 into sin square x minus y divided by 2. Now here which term we can take common? So here 4 cos square x plus y by 2 we can take common. Same way here also 4 cos square x plus y divided by 2 we can take common. So 4 cos square x plus y divided by 2. Now in another bracket written in remaining term. So cos square into bracket x minus y by 2 plus sin square into bracket x minus y divided by 2. Now cos square, we know that cos square theta plus sin square theta, that means what? Theta, that means here x minus y by 2. So here also x minus y by 2 form is present. That means both this theta form is same. So here apply this identity cos square theta plus sin square theta in place of written 1. So hold this term written 1. So remaining term is our answer. So 4 cos square bracket x plus y divided by 2 into bracket 1 is equal to RHS. So first of all here first bracket, here apply the identity c plus c, that means 2cc. In second bracket apply the identity s minus s, that means 2cs. Now after whole square form is present, so remember this term whole square, that means all these term written, apply square separately. Now after common, which term common in both these terms? So here 4 cos square x plus y divided by 2 common in both these terms. So remaining term we can return in another bracket. Now apply the identity, so here we get final answer. Now next question. Question number 6. Question number 6. In bracket sin 7x plus sin 5x bracket over plus into bracket sin 9x plus sin 3x bracket over upon in denominator term cos 7x plus cos 5x plus in another bracket cos 9x plus cos 3x is equal to, prove that tan 6x. So again start from the LHS. Now in first bracket s plus s form here apply. S plus s, that means 2sc. In second bracket also s plus s form is applied. Now in case of denominator term c plus c, that means 2cc form apply here. So is equal to, now here written s plus s, that means 2 times sin into bracket 7x plus 5x divided by 2 into cos 7x minus 5x divided by 2 bracket over plus here s plus s. So again here apply 2 times sin 9x plus 3x divided by 2 into cos bracket 9x minus 3x divided by 2 bracket over upon in denominator term c plus c, that means 2cc means 2 times cos 7x plus 5x divided by 2 into cos 7x minus 5x divided by 2 bracket over plus again here c plus c form is present, so again written here 2 times cos 9x plus 3x divided by 2 into cos 9x minus 3x divided by 2 bracket over. Now after simplify this term, so 2 times sine 7x plus 5x, that means 12x divided by 2, that means sine 6x into cos 7x minus 5x, that means 2x divided by 2, that means cos x. Same way in plus, here we can written 2 times sine 9x plus 3x, that means 12x divided by 2 means sine 6x into cos 9x minus 3x, that means 6x divided by 2 means cos 3x upon same in denominator term, here written 2 times cos 6x into cos x plus 2 times cos 6x into cos 3x. Now in numerator term and denominator term 2 we can take common and after cancel out. Now here in numerator term sin 6x also we can take common. So remaining term cos x plus cos 3x. 2 already we can take common and after cancel out upon. Otherwise here we can take common 2 times sin 6. Same way in denominator term, here we can take common 2 times cos 6x. Remaining term cos x plus cos 3x. Now here 2 cancel, in bracket term also cancel. So remaining term is sin 6x upon cos 6x and sin upon cos, that means here written tan 6x is equal to RHS side. Clear? Okay. Now in question number 8, here our question is find out the value of sin x by 2, cos x by 2 and tan x by 2, and here condition is given tan x is equal to minus 4 upon 3. So this type of question is most important question. Weightage of this question is 4 mark. Remember, so question number 8, 9 and 10. Our question is find out the value of sin x by 2, cos x by 2 and tan x by 2. So now solve question number 8. Tan x is equal to minus 4 upon 3 and here condition is present x in second quadrant, right? So first of all here tan form is present, tan convert into the form of sec form. So our first step sec square x is equal to 1 plus tan square x. Now after using by this identity 1 plus minus 4 upon 3 whole square Now take LCM, so 9 plus 16 divided by 9, that means 25 divided by 9. So sec square x is equal to, here we get 25 by 9, cos square x is equal to 9 by 25. Now here second quadrant is present. Now remove for the square, so here we get plus or minus 2 value, but here second quadrant is present, and in second quadrant value of cos is negative, so here written cos x is equal to negative sign, minus 3 by 5. Now after, our question is find out the value of sine x by 2. So sin x by 2, we know that the result of sin x by 2 is equal to, uh, we know that one result cos 2x is equal to 1 minus 2 sin square x, right? Now cos 2x is equal, here 2x is present, so here x is present. But suppose here cos x is present, so here written 2 1 minus 2 sin square x by 2. Now square form written this side, means 2 sin square x by 2 written this side, and 1 minus cos. So 2 sin square x by 2 is equal to 1 minus cos x. Now divide by 2. So sin square x by 2 is equal to 1 minus cos x divided by 2. Now our question is find out the value of sin x by 2. So here, okay, here we can written sin square x by 2 is equal to 1 minus cos x divided by 2. So sin square x by 2 is equal to 1 minus, value of cos x is minus 3 by 5 upon 2. Now take LCM, so 5 plus 3 divided by 10, that means 8 by 10, that means 4 upon 5. So remove for the square root. Okay, now here second quadrant is present. In second quadrant value of sine is positive form, so here written remove for the square root, so here written 2 upon under root 5. So we get the value of sine x by 2 is equal to 2 upon under root 5. Now next value is cos x by 2. Here we get the value of cos x, but our question is value of cos x by 2. So same identity using here. In another formula of cos 2x is equal to 2 cos square x minus 1. Here 2x is present, so here x is present, here only x is present, so here written x by 2. Now minus sign written for this side, so 1 plus cos x divided by 2 is equal to cos square x by 2. So now our second identity is cos square x by 2 is equal to 1 plus cos x upon 2, 1 plus, okay, now the value of cos x is equal to minus 3 by 5, so here written 1 minus 3 by 5 upon 2. Now take LCM, so 5 minus 3 upon 2, so therefore cos square x by 2 is equal to 2 upon 10. Now after cancel out these terms, so therefore here we get the value of cos square x by 2 is equal to 1 by 5. Now again remove for the quadrant, so here the value of cos is negative in second quadrant, so remove for the square root, and written here cos x by 2 is equal to minus 1 upon under root 5. So our second value we get cos x by 2 is equal to minus 1 by under root 5. Now our third value is tan form. So therefore here tan x by 2 so is equal to written here sin x by 2 upon cos x by 2. Sin x by 2 in place of written 2 upon under root 5 upon cos x by 2 in place of minus 1 upon under root 5. Under root 5 cancel out. So tan x by 2 is equal to minus 2. Clear? Now example number 29. Question number 9 and question number 10 also solve in similar method, same way, same result use. And after solve this example, first of all equation converting to the form of cos form, and after remaining formula converting to the means sin x by sin square x by 2, that means 1 minus cos x upon 2, cos square x by 2, that means 1 plus cos x divided by 2. So first of all convert the term in cos form. Example number 29. This question is also important. Weightage of this question is 3 mark or 4 mark. So prove that cos square x plus cos square in bracket x plus pi by 3 plus cos square bracket x minus pi by 3 is equal to 3 upon 2. So we know that cos square x, that means 1 plus cos 2x divided by 2. So first of all start from the LHS side, and cos square x in last example already convert this identity. Cos 2x is equal to 2 cos square x minus 1. Now interchange the position. So here cos square x is equal to, we get one result, 1 plus cos 2x divided by 2. Same way plus cos square x plus pi by 2. So again same result x, that means we can consider this term. So 1 plus cos 2 into bracket x plus pi by 3 upon 2 plus in last term also 1 plus cos 2 into bracket x minus pi by 3 upon 2. Now in both these term written separately, so 1 by 2 plus 1 upon 2 cos 2x, same way plus 1 by 2 plus 1 upon 2. Now 2 multiply in this bracket, so cos 2x plus 2 pi by 3. Same way in last term plus 1 by 2 plus 1 upon 2 cos 2x minus 2 pi by 3. Now 1 by 2 plus 1 by 2 plus 1 by 2, so add this number. So here we can written 3 upon 2 plus 1 by 2 we can take common in second, 4 and 6 term. So here remaining term cos 2x plus cos into bracket 2x plus 2 pi by 3 plus cos into bracket 2x minus 2 pi by 3 bracket over 4 bracket. Now, after in last two terms, see here first term is different and second and third term is similar manner. So here in last two term, apply the identity C plus C. Now C plus C, that means here we can written 2CC. So is equal to 3 by 2 plus 1 upon 2 in bracket cos 2x plus here apply the identity 2cc. Now simplify this term. So here we get the value of 2 cos 2x into cos 2 pi by 3. Right? Simplify this term. So here we get this type of result.